Alright, so welcome to another video. In this episode, we are going to look at how we can use the midpoint rule to estimate a double integral. Alright, on this board here, we have this particular double integral. Alright, where D, the domain, right, has been given with this range. Okay, so this range over here, right, 0 less than x, less than or equal to x, less than or equal to 1, and that of 1 less than or equal to y, less than or equal to 2, means that the bottom of y is 1 and the top is 2, right? And the left side of x is 0 and the right hand side is 1. Okay, so that is the range of x and y. All right, so from here, we know the range of x and y to be 0, 1, and 1, and 2. Okay, we have been given this, a rule with m equals n, that is equal to 2. Okay, so m is equal to n, and that is equal to 2, right? This means that m is equal to 2, n is also equal to 2. So if you have this, then it means that you're going to multiply this by this to have the total subrectangle of that particular figure. All right, so you are going to have m by n, and that is equal to 2 by 2, which is equal to 4. Right, so you are supposed to have 4 subrectangles within your rectangle. All right, so we consider the range of x and the range of y, right? So here, let's draw the graph so that we can find the midpoint, the center, and the point of intersection of the graph, that is the rectangle. So we draw our graph. This, of course, a sketch, right? So we have our x and our y, right? The range of x, right, is 0. Let's say our 1 is somewhere here. And that of y is 1 and 2. So let's say our 1 is here. Let's bring it up a little. 1 is here and our 2 is somewhere here, right? So we have to know where this point meets the intersection of this particular point, right? So you can see that this, when you move this to this section, right? This to this section, 1 and 1, this is where they are meeting, right? This is where they are meeting. So, and also this 1 and 2, right? This 1 and 2, this is where they're meeting, right? So you can see that this is just a dotted line for us to be able to trace our bigger triangle or our bigger rectangle, right? So here, this becomes the bigger rectangle, the bigger rectangle. Okay, the bigger rectangle. So from here, we want to know the intersection, right? The intersection. So you add this and this, right? And that becomes the intersection of this particular figure, right? So this and this, you get 1 divided by 2, and that becomes half, right? This and this is also 3 divided by 2, and that also becomes 3 on 2. So we have this here. Okay, so now we have the intersection of this rectangle. That is from here to here, the intersection is this, and from here to here, the intersection is this. Okay, so now we know our intersection. We want to find the midpoint. All right, so the midpoint is going to be, if you want to know the midpoint, you know, the center for this particular rectangle is going to be this section, this section, this section, and this section. Okay, so you want to know the midpoint so that you direct it to the center. So in order for you to know that, you add this and this, okay, to know this. Okay, so 1 plus 3 on 2, right? And that is going to be 5 on 2 divided by 2. All right, so that's going to be 5 on 4, right? So that is the section for this, right? So you trace it down here. You want to know the section for this part, the midpoint of this part. Okay, so with that, so you add this and this. So 0 plus half, and that is half, divided by 2, that is also 1 on 4. So we have this section to be 1 on 4. Okay, so now we have this, we have 2 midpoints, okay? 11, 2 more. All right, so we want to know this section as well, this section and this section. Okay, so if you want to know this section, you add this point and this point. So if you add 2 plus 3 on 2, that is going to be 5 on the 7 on 2. 7 on 2, right? 7 on 2 divided by 2 is going to be 7 on 4. So we partition this section, right? So we have this part to be 7 on 4. We want to know this part as well. So we trace this also here, because this comes to this section and also goes to this section as well, right? So now you have this, you have to move it to this section, right? So this to this, right? You want to know what is here. So you add this and this. Okay, so half plus 1, that is 2 on 2, right? So you're going to have 3 on 2, right? And divided by 2 is going to be 3 on 4, right? So we have this section 2 to be 3 on 4, right? So now we have all the midpoints. We have all the midpoints of this sub-rectangle. This is the midpoints to this, the midpoints to this sub-rectangle. This is the midpoints. Same applies to this section and over here. Now we want to know the center, right? We want to know the center of this point, right? So with the center, what you do is that you take this point, you know, this, when you trace it to this section, you have your first point, right? So you're going to have your first point to be this to this. That is going to be 1 on 4 and 5 on 4, right? This to this, right? This to this. So we have 1 on 4 and 7 on 4, right? You consider this right here. So this to this to this, right? That is also 3 on 4 and 5 on 4, right? This to this. So we're going to have 3 on 4 and 7 on 4. right? So we have our midpoints, right? So we use this midpoint to evaluate the function. So when we evaluate each point on this function, the value you're going to have will become the center of this particular subrectangle, right? So I know that each subrectangle has area, right? That is the small change of the area, right? You know that rectangle has, for you to know the size of the rectangle, you have to come here, this part, right? That is going to be 1 minus 0 divided by 2, and that is going to be half, right? The y range, also you have 2 minus 1 divided by 2 is equals to half. So you're going to have the small change in the rectangle, right, going to be half times half, right? And that is going to be 1 on 4. Okay, so now we have the small change, that is the change in the area, right? That is 1 on 4. So when you evaluate each point on this function, then you multiply it by the area. Each of them, you do the same thing, right? When you are done, you sum all, and that becomes the midpoint, the value of the integral, right? So let's move on to this section. So we come here, when you come here, evaluate at this point, this function at this point, right? So this integral, which is x minus 3y squared dA. We want to evaluate this function at this particular point, right? So at 1 on 4 and 5 on 4, right? We pick the function, which is x minus 3y squared here. We substitute the values, which is going to be 1 on 4 minus 3 into 5 on 4 squared, right? So it's going to have 1 on 4 minus 3 into 25 on 16, right? So this, when you evaluate it, will get negative 4.4375. Negative 4.4375. So we have to evaluate it at this point also, right? I don't want to clean the graph, right? This graph is very, very important. When you get this graph, you are done with everything, right? So I want to maintain the graph. So I want to write this value somewhere here. So at this point, 1 on 4 and 5 on 4, we had negative 4.4375. Right, so let's evaluate it at the second point. At the second point. So at the second point, which is 1 on 4 and 7 on 4, we're going to have 1 on 4 minus 3 into 1 on 4, 7 on 4 squared. So we have 1 on 4 minus 3 into 49 on 16, right? So this basically we're going to have 1 on 4 negative 8.937, right? So we have this at this point, we have it as negative 8.937.5, right? That is the second point. So we evaluate the third point as well. So that is also 3 on 4 and 5 on 4, right? So we're going to have 3 on 4 minus 3 into 5 on 4 squared. So that's going to be 3 on 4 minus 3 into 25 on 16, right? So that's going to be what? Negative 3.9375. So we also have the third to be negative 3.9375. Okay, at the last point here, at the last point, which is 3 on 4, 7 on 4, right? We're going to have 3 on 4 minus 3 into 7 on 4 squared. So we're going to have 3 on 4 minus 21 on 4, 21 on 16, right? So that's going to give us negative 8.4375. So this you're going to have negative 8.4375, right? So now we have been able to evaluate each of the points on this particular function, right? So let's come to the graph again. So in the graph here, the center of this particular subrectangle right here is going to be the negative 4.4375, right? That covers this section all, right? And the value for this section as well is negative 8.9375. When it comes to this point, that is also negative 3.9375. When it comes to this section, we have negative 8.4375, right? So these are the center for each sub-rectangle. Okay, so this is how you represent the graph for a midpoint rule. So once you have these evaluated points, sum them, right? So you're going to quote your formula, which is you want the integral, right? So integral of the function, right? So integral is going to be summation I, right? I and j of a function. Now you are interested in the summation of the centers, right? The centers, you got it from the midpoint. So it's going to be S something, so showing that whether it's a midpoint or a center, right? So S bar or Y bar, right? So this is what you have here. When you finish summing everything, multiplied by the change in the area, right? So here we are going to have negative 4.4375 minus 8.9375 minus 3.9375 minus 8.4375, all multiplied by 1 on 4, which is the area, the small change, right? So that is it. So when you sum everything in this year, you're going to have negative 25 points. Everything. When you sum everything, you're supposed to have negative 25 point something, 0.19 times 1 on 4. So everything is supposed to have negative 6.4375. Okay, so we have the integral of the function evaluated to be negative 6.4375. Okay, so that is the process we use to evaluate a particular integral that is very, very difficult to compute the exact value when you are given a double integral. Here is the way out. The midpoint rule, well explained. So I hope you enjoyed the lesson. Don't forget to subscribe, share with your mates, and I'll give you more updates. Don't stop learning. The moment you stop learning, you are not going to live anymore. Recognition to prime new things. Bye-bye.